All right, hello, this is Mrs. Query again, and I am lecturing on Chapter 1, Section Point 6, Solving Systems of Equations. So now I have more than one equation and I need to solve them. What does that mean to solve? Okay, we're going to talk about that. This is still part of the same essential standard I can create, solve problems with, graph, systems of linear equations and inequalities. So here we go. Linear systems can have 0, 1, or infinite number of solutions. Okay, that's kind of weird, right? But we'll talk about what that means. These solutions can be described graphically as two lines that, what happens here? We do not intersect. If they have, I have two lines that are parallel to one another, each line has its own equation, and they do not intersect, there are no solutions. There's nothing that would, I do not have a point on these graphs that are in common with one another, okay? So there is no solution for lines that are parallel, they don't intersect. But if I have a solution, or I have a line that is, two lines and they intersect at one location, which is probably what we would assume is most common. I have one location, I have an X and a Y value that satisfies both equations. I can use that same point for both equations and maintain my equality, okay? So that is considered a solution for that system of equations. But what if I had two lines that are on top of one another, identical to one another? There is an infinite number of solutions in that situation. There is an infinite number of points on line 1, and those exact points will also hold true as far as it will, the equality will be met on the second line because they're on top of one another. So there's an infinite number of solutions. So there's 3 different situations. So we want to find, oh, these actual terms should be up here. So let's talk about that. This is a situation where their parallel is considered inconsistent. The second one, where there's one solution and they intersect at one location, is considered consistent, but the lines are independent of one another. And the third one is considered consistent and dependent to one another, because they, if one moves, the other one has to move with it. Okay, so we are going to learn how to solve these systems of equation using 3 different methods: substitution method, elimination method, and graphical. Okay, I want to find out if there's a solution, and is it infinite number, or is there no solution, or is there only one? So let's do a couple of examples. Solve the system of equations by using substitution. See if I can figure that out. Where is that? Okay, so what does that mean by substitution? That means I want to solve for one of the variables. I'm going to solve for y in this first equation. So let's say I'm going to isolate y. I do that by adding negative 2x to both sides, and I find that y is equal to negative 2x plus 7. And I use my equation number 1 to do that. Now that I have that, I am going to substitute it into the y in the first equation. Okay, so I will then take 5x minus 3 times y, but now substitute in for y 2x plus 7 equals 23, and then I will solve for x. But before I do that, I have to distribute the 3 through the entire binomial, and I will get, let's see, positive 6x minus 21 equals 23. I need to add the 2 x's, so I'm combining like terms. I'm moving 21 over, and I will get 44. I will solve for x, and x is equal to 4. So now I have my value of x. Remember, I'm trying to find a solution of the system of equations, which is the location where those 2 lines intersect. I'm not done yet. I only found one part of that point. So I've got to take that 4. I would then plug it back into this equation for y. I would find that y is equal to negative 1. And so here is my solution. That is the point in which the graph, the graph of those 2 lines intersect, and there is only one solution. So it is considered a consistent and independent solution. okay, or system of equations. All right, so why don't you try this one on your own? I'd pause it, try it, and then I will check your work. Okay, so I want to solve for y, and I will use, since this y is all by itself, I would use this equation to solve for y, and I would find that y is equal to negative 6x minus 27. Okay, and then once I have this value for y, I then will plug it into the second equation, and I will come down here and write 3x plus 8 times y, which is 6x minus 27, which we found from the first equation, is equal to 9. Then I have to distribute the 8 through. And then I need to add like terms and simplify. So add the 3 and the negative 48, and I will get negative 45x is equal to 225, and then solve for x, which is equal to negative 5. I'm not done yet. I only have one variable. I need the other variable, and so I'm going to plug that back into this equation for y. I will find y to be negative 6 times negative 5 minus 27. So y is equal to 3. And so my solution is negative 5 and 3. That is the point at which those two lines intersect. I have one solution. I have solved that system of equations, okay? So that's the first one, by substitution. What about solve the system of equations using elimination? I want to eliminate. I'm going to add these two equations together, and I'm trying to eliminate one of the variables. I need either the x or the y to disappear. And this in sample or example A, I don't have to manipulate this equation at all. I can just go ahead and add these two, because negative 2x plus x is equal to 0, but I have negative 9 plus 6, negative 9y plus 6y is equal to negative 3y, and then 34 plus a negative 28 is equal to 6, and I find y to be equal to negative 2, and then I can plug this back into this equation up top. Either one, doesn't matter which one. You're going to find out what x is, and I will find that 2x is equal to plus 18 is equal to 34, and then I will find x to be equal to 8, and my solution then is 8 minus 2. So x 8, y negative 2. That is the solution for that system of equations. Okay, what about this problem here? Go ahead and try this one on your own. Pause it and try it. Okay, one of the things that I've noticed is that we have something very close to what we're looking for. We want to eliminate. So I can do a couple different ways. The same exact thing, it has the same effect. I can change the every term and multiply each side by negative 1. I guess that's what I'm trying to say. So positive 4x becomes negative 4x. This becomes a positive 5y, and this becomes a positive 12. And now that I have that, I can add those two equations together, and the y's will drop out. So 6x minus 4x is 2x. The y's cancel, that's a 0. And then I have negative 8 plus 12, so I have a positive 4. And then I can solve for x, which will be equal to 2. And then I will plug that into either one of those. And I will find that I'll plug it into the first one. 12 minus 5y equals negative 8, and I will find y to be equal to 4, and then I will have an answer of 2. That's what my x value is, and y is 4. That is the solution for that system of equations. Okay, hope that makes sense. Moving on. Okay, so we are also trying to solve by elimination. So I want to be able to add the two equations together and have one of the variables drop out. And what I'm seeing here is that I'm not quite there. I'm gonna multiply the bottom equation by 2. So what I do on the left, I have to do on the right. So I'm gonna multiply this side by 2, and then I'm gonna multiply the right-hand side by 2, and I'm gonna rewrite these equations. 2x minus 12y equals 3. And then I have negative 2x plus 12y equals negative 18. And I'm going to add the two equations together. And I get 0x plus 0y equals negative 15. So what does that tell you? What do you think that means? Is 0, this is 0 equal negative 15. Is that true? No, that is not true. And so this is no solution, or they are inconsistent. There is no solution. All right, let's continue on. Why don't you try D? All right, I'm going to find that I need to multiply both. If I want to do this by elimination, I'm going to have to manipulate this. So I'm going to multiply the top one by negative 2 and the bottom by 3. And so I will, let's say I'm looking at the x coefficients. I see that there's a 3 in one equation and 2 in the other. And so the least common multiple of the 2 and the 3 is 6. So I figure out what I have to multiply those by to get 6 and make sure one of them is negative. And then I can solve this problem using substitute or elimination. And then I get 6x plus 12y equals negative 96. I add them together. And what do I get? Oh, this is wrong here. I find that 0 equals negative 96. And so we know that that is not possible. So we will say that this is no solution. And again, it's inconsistent. Okay, moving on to letter E. I would like to, again, you solve by elimination. So I can tell that, let's look at the x value coefficients, negative 35 and 7. The least common multiple or of those is 35. So I've got to multiply 7 times 5 to get that. So I'm going to multiply this whole entire equation by 5. And so I will have, let's see if I can do different colors, negative 35x plus 40y equals 55. And on the bottom, I will have a 35x plus 40y equals negative 55. And I find that 0 equals 0. Okay, that's weird. What do you think that means? In this situation, I have an infinite number of solutions. Infinitely many solutions. So 0 equals 0. There's no one point. There's many, many, many points. All right, why don't you try F? Okay, so if I'm trying to do this by elimination, I will have to multiply both equations by something. I'm going to look at my x components, or my integers in front of x. I have a negative 4 and a 6, and 4 and 6, what its least common multiple is 12. So I'm going to multiply the top equation by 3, and I'm going to multiply the bottom equation by 2, and then I will solve. So the top equation becomes negative 12x plus 6y is equal to negative 18, and the bottom equation becomes 12x minus 6y is equal to 18. And then if I were to add the equations together, I find that 0 plus 0 equals 0. And once again, I have an infinitely many number of solutions. Okay. All right. last item of the day, solve the system of equation by graphing. So now we're going to find the point on the graph at which they intersect by actually putting them on the graph, and then learn how to use our calculator to do that. Okay, so here's my first equation. I will use red for this one. And what do we know? What do we know about this type of graph, or this type of equation? Y equals mx plus b. Well, m is the slope and b is the intercept. Well, what does that intercept mean? That means that that is the value of y when x is equal to 0. So that's a good place to start. So I would go to -1 on my y-axis, and I know that at x equals 0, y is equal to -1. And then from there, I can start looking at the slope. So the slope is a +2. So I'm going to go up 2 and over 1, up 2 and over 1. Okay, so let me try to clean that up a little bit. 1, 2, over 1. I can go up 2, and I do a few points. That's just my style. I don't like to only have a couple points. It is difficult for me to draw on an iPad. So here, if I don't have a straight edge, but there's my best attempt at drawing that line. Okay. All right. Next is the second line. -8 is my y-intercept. I'll use blue. So at x equals 0, y is -8. So I got to go to this location right here, -8. And then I got to find I find that the slope is 5 halves, -5 halves. So I'm going to go up 5, 1, 2, 3, 4, 5, and over 2, 1, 2. So here's my first point. Okay, I'm going to go up 5, 1, 2, 3, 4, 5, and over 2, 1, 2. Okay, so there is a couple points on that line, and I then do my best to draw that line, and then I have to take a peek at that and try to come up with my solution. So what is the point, the x and y coordinates of where that graph intersects, those two lines intersect? So what is the value of x? It's negative, in my opinion, 1.5. And what is the value of y at that location? I'm going to say it is -3.5. Okay, that's my graph. Okay, with minimal tools. Now, how accurate do you think that is? Is it an estimate? I personally believe it's an estimate. So what we need to do now is pull out our calculator. So once again, you're going to go to this button right here, y equals, and you're going to delete any data that's there for y1 or y2, and you will then enter into the first y equals 2x minus 1. So 2x, where do I find the x? I put this button right here, where it has the values of x, comma, t, comma, theta, comma, little n, okay? That'll put an x in that equation. So 2x minus 1, and then you will down arrow to the y2 line and type in -5/2 times x and minus 8. And by the way, be very careful. There is a lot of times you want to use the negative sign. I'm sorry, the minus sign as a negative. There is a very unique, distinct negative key on your TI-84. It's the bottom, very bottom right-hand side. So now that I've actually added that, I can go push zoom and say maybe the standard view, and I can see it. So I can actually see the two graphs. So there is what I'm looking at now that I've pushed that zoom. There's what I want. I want that point right there. So, but I need to do some calculation. So if you'll notice right above this trace, it has a calc, C-A-L-C in blue. So I want to hit second key and then hit that calc, and you should see this screen right here. And what we want to do is find the intersect of those two lines. So you will hit 5, and it will then pull up this screen right here. And so it's got a point on, it's kind of confirming that it knows what you're asking for. And so it goes first curve question mark, and it's got a location. I don't know if you can see it. if there's a point usually on the graph and it says, yes, I'm good with that. So then you hit enter, okay? And then it puts its cursor on the second curve and I'm good with its location now. Then it says guess. And what it wants you to do is move your cursor to approximately where that Y, those two lines intersect, and then you hit enter and it will give you the precise location. When you hit guess, you're just helping the calculator get there faster because it has an iterations that it does, okay? And so what did the calculator tell me that my intersection was? That X is equal to 1.556 and Y is equal to negative 4.111. And notice that these are slightly different than the graph, and that's okay, that's normal, all right, because I've estimated that based on that graph, and this calculator calculated it precisely. All right, that is my the end of my lecture for today. Reach out to me if you have any questions, and once again, there is help on one of those YouTube links for graphing with your calculator if you need it. Have a good day.